Hello everyone, this is Amit Latigra. In this video, I'm going to demonstrate how can we generate a Fibonacci series for given number of terms. So next step is let's understand first what a Fibonacci series is. So Fibonacci series is a series which has first two terms fixed as 0 and 1. So these two terms are fixed. Then to get the next term, we need to add previous two terms. So here it is 0 and 1. If we add it together, we'll get the next term, that is 1, third term of Fibonacci series. To generate the next term, again addition of previous two. So 1 plus 1, it is 2. 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13, and so on. So this is a Fibonacci series. So as I said, let's repeat it again. First two terms are fixed, that is 0 and 1. These two terms are fixed for Fibonacci series. To generate the third term, addition of previous two terms, 0 plus 1, we'll get third term. To generate the fourth term, previous two terms, second and third term. 1 plus 1, we'll get 2. Similar way, 2 plus 1, by adding these two terms, we'll get 3. 3 plus 2, by adding this, we'll get 5. 5 plus 3, by adding this, we'll get 8. 8 plus 5, 13, we'll get this, and so on. So this is a Fibonacci series. And in this example, if I consider up to 13, then we are having total 8 terms. How can we do this? How can we do this? As I said, first two terms are fixed, say 0 and 1. These two are our first two terms. Let's consider it as number 1 and number 2. To get the next term, that is third term, let's consider it as a number 3. We need to add previous two terms, that is number 1 and number 2. So number 1 plus number 2. So what is my number 3 is 0 plus 1 in this example, and it is 1. So up to 3 terms, it looks very simple. What about next term? To generate the fourth term, what we require is we require addition of previous two terms. As of now, what I did is 0, 1. I added 0 and 1 to get the next term. Now in next term, this is basically my number 1. This is my number 2. And this is number 3 at this point of time. To get the next term, I need to add these two terms. 1 plus 1. In this way, I will get result as a fourth term, that is 2. So for 2, this number 2 of previous terms is basically a number 1, and number 3 of previous term is going to become number 2. So now here if I consider number 1 plus number 2, then here I will get it as a number 3, isn't it? 1 plus 1, then 2. Let's move forward. 1 plus 2. Result is 1 plus 2, that is 3, my fifth term. So for fifth term, if you can check, then whatever the number 2 in previous term is number 1, whatever the number 3 in previous term is number 2, and in this way we are getting number 3 as 3. So here it is a repetition. Again 2 plus 3, 5, and so on. So here repetition meaning we are continuously adding two numbers to get the next number. So this repetition can be achieved using a loop. But if you can check to generate the next term, like I did in this example, number 2 we are assigning to number 1 of previous term. Similar way, number 3 we are assigning as a number 2 to next term. Again, number 2 becomes number 1, number 3 becomes number 2, and so on. Let's consider it in more deeper way. Here, number 2 we are considering as number 1. So number 2 is nothing but number 1, and number 3 is nothing but number 2. Number 3 is nothing but number 2. So here, let's correct it. Number 2 we are assigning into number 1. So number 1 is equal to number 2. Number 3 we are assigning into number 2. So first we are assigning value of number 2 to number 1, then number 3 to number 2. And then if I write number 3 is equal to number 1 plus number 2. Let's consider the case with the similar example. Here number 2 is 1, number 1 is 0, and number 3 is number 1 plus number 2, 0 plus 1, so 1. So what is the number 2? That is 1. So in this example, number 1 becomes 1, number 3 is also 1, which I am assigning into number 2 now. So 1 plus 1, number 3 becomes 2. So this is my next term. Now, once again, we need to repeat the process. Number 1 is nothing but number 2, and number 2 is nothing but number 3. Likewise, here this further becomes number 1, this becomes number 2. So repetition, number 3 is equal to number 1 plus number 2. So this is the next iteration. So here number 3 is 2, number 1 is 1, number 2 is 1. So number 2 is 1 here, which I am assigning it to number 1, and number 3 is 2, which I am assigning it to number 2. So 1 plus 2. 1 plus 2, that is 3, which is my next number. So here, if you can check, it is a repetition. Replacing value of number 1 and number 2, adding together. If you can check, this we can consider as a loop. So this way we can generate a Fibonacci series. How? Let's understand it in flowchart. I need to start. Let's take an input from the user, meaning how many terms of Fibonacci series user wants to generate. This ideally should be greater than 2 by considering a reason that first two terms of Fibonacci series are fixed, that is 0 and 1. So let's take an input. First two terms are fixed. So let's consider here it as the number 1 as 0, number 2 as 1. So these two terms are fixed, 0 and 1. Let's display it on screen as first two terms of Fibonacci series. So print number 1 and number 2. Now I need to generate remaining iterations. So first and second iterations are fixed, that is 0 and 1. I need to start with next iteration, that is 3. So next iteration is 3. So I am at third iteration. First and second numbers are already we have printed on screen. Then we require some condition for the loop. If it is false, means we have generated enough number of terms for Fibonacci series. We need to stop the program. So is my iteration less than or equivalent to total number of terms? This we need to check. I'll come back to this equal sign, whether we require it not in some time. But let's first consider what if it is true. So currently we are in third iteration. Here what we need to do, we need to find next number. So that is number 3. It is nothing but addition of previous two terms as I explained here. And then we are updating the value of number 1 and number 2. So finding this number displaying on screen as a next term of Fibonacci series, updating value of number 1 and number 2, and changing the value of iteration for moving to the next step. So what I'm doing here, I'm changing the value. Number 2 becomes number 1 now. Number 3 becomes number 2 now. And then we are changing the value of iteration. So in the beginning, I said we'll come to this condition at later stage. So we are in third iteration and we are displaying third term as well. Then we are changing the value of iteration to next one. So whether we require here less than and equal both or only less than. So that is the question I raised earlier. So as we are in third iteration, we are printing third number and then we are changing. So this condition remains fine at this point of time. And we need to come back here. So this is a loop. Now, let's check how it executes. So basically, what I want to consider here is practically, let me show you how value of number 1, number 2, and number 3 changing and how we are displaying it on screen. So initially number 1 is 0, number 2 is 1. So number 1 is 0, number 2 is 1. We are printing number 1 and number 2 on screen. So let's print it here. First two terms 0 and 1. Then value of iteration is 3 here. Let's take first input value n here. For an example, I want it as a 6. So I need 6 terms of Fibonacci series, out of which already first two terms, that is 0 and 1, printed. So that's the reason I started with iteration as 3. So here value of iteration is 3. 3 is less than or equivalent to 6. It is true. It is true. So number 3 is equal to number 1 plus number 2. So number 1 is 0, number 2 is 1, 0 plus 1. So value of number 3 is 1. We are displaying it on screen. So value of number 3 is 1. Now, Number 1 is equal to number 2. So value of number 2 I am assigning to number 1. So now number 1 is 1. Value of number 3 I am assigning it to number 1. So this 1 I am assigning it to number 2. Iteration is equal to iteration plus 1. So value of iteration is 4. So at this point of time, we produced 3 terms of Fibonacci series. Condition 4 less than or equivalent to 6. True. Number 3 is equal to number 1 plus number 2. So number 1 is 1, number 2 is 1. 1 plus 1, number 3 becomes 2 now. Display number 3. So 2 I'm displaying on screen as a fourth term of Fibonacci series. Number 1 is equal to number 2. So number 2 is 1, which I'm assigning it to number 1. Number 3 is equal to number 2. So number 3 is 2, which I'm assigning it to number 2. Iteration is equal to iteration plus 1. So next value of iteration is 5. Condition 5 less than or equivalent to 6. It is true. Number 3 is equal to number 1 plus number 2. So 1 plus 2, it is 3. Displaying on screen as 3, fifth term of Fibonacci series. Now number 1 is equal to number 2. So this 2 I am assigning to number 1. And number 3, that is 3, I am assigning it to number 2. Iteration plus 1. So in this case, it becomes 6. 6 less than or equivalent to 6. Still it is true. Next number is equal to number 1 plus 2. So 2 plus 3. 2 plus 3. So number 3 becomes 5 now. Displaying on screen. So 5 we are displaying is a sixth term of Fibonacci series. Number 1 is equal to number 2. So here it is 3. Number 2 is equal to 3. So here it is 5. Iteration is equal to iteration plus 1. So now it is 7. 7 less than or equivalent to 6. It is false. Stop. So on screen, this is the output which we are expecting. First 6 terms of Fibonacci series. So this is a simple flowchart. Now using this flowchart, let's write our Python program. So we require an input from a user. We are initializing 2 numbers. We require 1 iteration, addition within the loop, displaying on screen, and updating the value of number 1 and number 2. So let's take an input from the user. Enter number of terms needed to generate or needed for Fibonacci series. Greater than 2. Or we can specify, ideally it should be greater than 2. Enter number of terms needed for Fibonacci series, which is greater than 2. Next, we require number 1. Let's have it 0, first term, number 2, second term, that is 1. Let's display it on screen, number 1 and number 2. So as per flowchart, we have displayed it. Now iteration, so that is a loop. So let's say for iteration in range, we need to start with 3 up to n, where n is inclusive. So starting with 3, if I write n, then it consider n minus 1. N is not inclusive. To make it inclusive, n plus 1. So for iteration in range, starting with 3 up to n plus 1. Within this, what we need to do is finding a third number, displaying on screen and updating the value. So number 3 is nothing but number 1 plus number 2. This is my loop, so colon, and print it on screen. So number 3 and then updating value of number 1 through number 2, and number 2 becomes number 3 in next iteration. So this is a simple program, but here this print statement is going to the new line. Let's understand it through output, what I mean to say. So let me execute a program. Oh, I made a mistake in the beginning. I don't require integer. I was uh, about to mention that we require typecasting. So this n is basically a number which we require from a user. So this is the error. We have cleared that error. Now enter number of terms needed for Fibonacci series. Let me enter 6 terms here. So 0 and 1 I'm getting on screen in one line, then all remaining in new lines. But I want each term in the same line. So let's first put space here to get the proper output message. And here, instead of going to the new line, let's keep it in the same line. Same here. And now let's execute it again. Number of terms we require 6. So 0 and 1. These are 2 terms, first 2, then third, then fourth, then fifth, and then sixth. Let's consider it one more time. Let's enter 10 terms. So 0, 1, first 2 terms, 0 plus 1, next term is 1, 1 plus 1, 2, 2 plus 3, 5, 5 plus 3, 8, 8 plus 13, 21, 21 plus 13, 34. So 1, 2, 3, 4, 5th, 6th term, 7th, 8th, 9th, and 10th. First 10th term of Fibonacci series. Similar way, let's say 50. So we are getting here first 50 terms of Fibonacci series. So this is a simple Python program to generate a Fibonacci series up to the terms which user wants. And this is a flowchart. I hope you like this video. Thanks for watching this video. Have a good time ahead.